Thank you so much for coming out today and for having us here. It's really exciting to be back here a year later after our first presentation at Consensus. So it's awesome to be part of the community and seeing so much progress being made in multiple verticals, protocols, implementations. It was really exciting to see a lot of our customers and partners presenting today and participating in panels, workshops, and so on. My name is Lana Kalashnik. I'm a global technology lead on partner solutions. So today, I'm honored to join the AMB team in showing some of the work that our internal teams have been working on and building solutions for our customers. We actually have a special treat today, so we'll have Jonathan Fritz, who is the head of blockchain on all of the service teams, helping us out and walking us through a little bit of the why behind the managed solutions. I know that we do get a lot of those questions. You know, why not use a database? Well, we will find out later on why. But also to get hands-on with AWS. Sometimes, you know, distributed or decentralized technologies and cloud, it could be a little bit different or difficult to put together, which is why we wanted to do this in an AMB workshop. So as a part of this session, we will spin up an AWS account, which is why all of you got the credentials to log into a burner account. So it will expire in a couple of days, but gives you an opportunity to not incur any of the financial burden of trying out this technology during the workshop. We will be spinning up an AMB network, and AMB is an abbreviation for Amazon Managed Blockchain. And while that's happening, we'll hear from Jonathan, and I will pause later on, and we'll just have a really interactive session. I won't be live coding. We'll be actually going around the room, myself and Mert, who is a senior big data and blockchain architect at Amazon. So we'll be working with you individually and kind of answering questions in a more intimate fashion rather than a webinar type of a situation. So without further ado, there we go. So we can get started with setting up your account. So if you don't mind logging into the AWS console, so there are multiple ways into which you can interact with AWS. So there's a CLI you can install on your instance, or you can log in from the web console and explore in more of a UI visual manner what kind of services we have. So we have a myriad of different solutions that cover a lot of technologies that is really important to understand if you're trying to position your platforms towards the enterprise. Blockchain doesn't exist in isolation, so you do have to integrate it with analytics and some of the systems that are better purposed for more centralized solutions. Also, mobile, IoT, if you're in supply chain or in medical or device manufacturing. It kind of makes sense to get familiar with a lot of those services. And also what's really, really important, some of the security solutions that we provide. So whether this is DDoS protection through something like GuardDuty or AWS Shield, or actually understanding how do you build out a proper infrastructure that is not exposed to the internet. So there is an opportunity to actually use our own private backbone to connect multiple nodes within a consortia together. And let me know if you're running into any issues. I'm going to give a couple of minutes to set up and access the account. And also, here's the link for the workshop we'll be going through. This is a public GitHub repository. So we will not get through majority of it today, but this is something you can work through. Zeppelin in the house. Nice. So we're going to go through this today, probably a couple of modules, and then the rest you will have available to you today and tomorrow to finish up, and also ask any questions. We will leave some time at the end for you to ask any AMB specific or QLDB or even partner solution specific questions. We'll probably take them on one-on-one basis. So let us know if you're into any issues there. Mm-hmm. That is one thing I did not prepare for. Yeah.
TradeStation _crypto, capital T, capital S, capital C. Consensus is the SSID.
Cool. All right. Do you need a little bit more time to get the links down, or are you able to access them? I'm going to pause for a second.
Connection's pretty slow right now.
Oh, is it? Of course. Yeah. Connection is slow. It's the best part of the conferences. And on these handouts, the first field is the account number, your username, and then the password when you're getting to the console. And just let me know by show of hands if we can proceed or we need a few more minutes. Good. Oh, and also another fun thing, we have some stickers. So if you guys want some, Jonathan is organizing them right now.
They're up here.
So he has the keys to the fun stuff. If you have the links down, I can proceed or. Mm-hmm. Sure. Sorry? No, it's going to be all running in the cloud. So actually, one of the cool things as a part of this workshop, we're going to play around with Cloud9, which is our cloud-based IDE. So it has a lot of really cool features. And one of them is that you can actually write Lambda functions, integrate with all of the IoT services, and run your test networks, integration, deployed chain code, et cetera, from within your terminal. So it's kind of a fun exploration. If you're a fan of Vim, then you're going to love this workshop because lots of stuff like that. All right, guys, I think we're ready to move on. So when we're talking about what does this workshop look like, we're going to be focusing on this second component today, so which is creating a base network. So how does Amazon managed blockchain work? We're going to hear a lot more about that from Jonathan, but essentially it's a way for you to easily spin up your network, choose an open source framework for blockchain of your choice, whether it's Hyperledger Fabric or Ethereum, and also add other AWS accounts. So it doesn't live within one account. You can actually invite multiple members from different accounts. You have an opportunity to invite members to join the network. And you can actually, there's some really cool integrations that our teams are working on as far as proposals on voting and removing members and actually specifying, let's say, what is the threshold of votes to make those decisions on the chain. You will also be able to add nodes, so you can create and configure peer nodes, and on which you will be storing the distributed ledger and deploying the applications themselves. So for this workshop, it's going to be an Angular front end, and we'll stand up a RESTful API to make sure that we're preserving the tier separation. And it's going to become really important once you're looking to upgrade your applications you're building on top of blockchain. So nobody canceled APIs and 3 tiers in a lot of ways. So we do want to make sure that whatever app is leveraging your ledger solution has the proper architecture. So here's just a little bit of a primer on what AWS infrastructure looks like for this solution, and where does blockchain live as a part of this. In this case, this is your Hyperledger node. So as a part of the managed solution, you will have the Hyperledger Fabric ordering service, which is the orderer, and also you have the member. So this is your logical unit within the network that will consist of a Fabric certificate authority and a peer node. Something that I've touched on briefly before this is Amazon VPC private link. So this is your way to expose APIs to your network members without going through the public internet. And it's going to become increasingly important if you're looking to work with regulated industries such as financial services or healthcare and life sciences. In my experience, a lot of them have different methods in which they inspect traffic. So a lot of them have to inspect packets as they're coming in, and they have different rules as to the way they do it from public and private internet. So it just makes deployment of networks a lot easier, and actually you can use this outside of blockchain. And also within your own instance of a different VPC for member A, you have your VPC endpoint, so this way you can communicate with this managed solution. And also you have your client node. So this is your client SDK with an implementation of whichever solution that you're building on top of. So that was step 1. Step 2 is scaling this out to multiple nodes. So in the last module of this workshop, which we will not be getting to, you'll have an opportunity to add different members to organizations from different accounts. And if you're looking to stand up a Hyperledger Fabric network on your own, it is kind of time intensive, and it takes you away from the true purpose of your standing up the solution is to derive business value for your shareholders, whether it's yourself or your team members. So by abstracting that away, we're providing a lot more improvements on reliability and security and scalability of the service. So here's what the solution would look like at scale. So you do have the managed component, but you also do have VPC endpoints and integrations for client nodes. And let me know if you have any questions on this. Sure.
So right now you only support Ethereum and the Fabric, no other blockchain
So that is not entirely true. So we also have Amazon QLDB from native services perspective. So that is a quantum ledger database. And Jonathan is going to go really into depth of why we're going with this approach. The way we see it is that technology is not something that you should build for fun. This is something you should build to solve a customer need. So because of that, we realize there is a need for a ledger database that doesn't necessarily need a distributed trust or decentralized trust.
Do you support Corda?
So Corda is, I'm glad you asked that. So I actually work with partner solutions. So we have launched Corda open source and Corda Enterprise quick starts. So essentially it's a way for you to spin up a logical unit of a Corda network within your account. So, and this is just like an overview. So with AWS, we have a lot of different programs in the way we engage with the community. So whether this is managed service solutions, which our customers are asking for, but also have a myriad of amazing startups. And Coinbase spoke at our reInvent conference in November. We work with partner ISV and integrator solutions, and I'm more than happy to go into that. But it's a little bit out of scope for this workshop. Mm-hmm.
Just one more thing, you were talking about compliance in compliance-driven industries. What is the compliance roadmap around SOC, FedRAMP, HIPAA certifications on the managed service on blockchain?
Oh man. freaked out. Sorry, I got a notification. So this is something that you should reach out to Jonathan Fritz as far as roadmap items.
I'll take that one.
Yeah.
I can take it. Well, when I get up there.
Yeah. Oh, is it you talking?
Guess I'm Mike.
Okay, yeah. So you can talk roadmaps with this guy. I'm just going through the workshop. And any partner solutions, reach out to me, or any other protocols that are besides what is the scope of this workshop. Happy to take them offline. So this is a typical layered architecture, and this is not something that will change. That you do need your RESTful API that connects to an SDK. So this is your way to make sure your network is upgradable. I know a lot of us are suffering from a POC fatigue. How do we stop building POCs and not going to pilots? We build in upgradability. So which is why you should build in RESTful APIs and take care of scaling on the back end. So let's get hands-on. So now that you do have access to your AWS console, we will be creating your first Fabric network with Amazon Managed Blockchain. So this is the console. I will give you a couple of minutes to type that in and to inspect it. So all of the features that I went over previously are pretty intuitive in the way that you would be creating a network, setting up some of the voting policies, inviting new accounts, and also spinning up your member and peer nodes.
So it says Ethereum coming soon. Very soon.
This guy. Any roadmap items that's not in scope of this workshop? So today we'll be focusing on a Fabric network.
And is there a difference between starter and standard?
Yes, that will be covered in the presentation in a little bit. All right, so is everybody at the console? Can I move on? Awesome. All right, guys, so this is the fun part. This is also available in steps in the GitHub repo that you saw the link to in the first slide. But this is essentially the steps for you to create your first Hyperledger Fabric network. So make sure you correct the correct region. So right now it is deployed in North Virginia, and then we'll be adding more regions as we go. But for the purpose of this workshop, that's the region you should be in. If you're struggling to find how to check that, please let myself, Mert, or Carl know, and we'll be happy to take a look and set it up for you. So once you get there, it's as simple as clicking Create a New Network. Right now, Hyperledger 1.2 is selected with plans to upgrade to 1.4 in the near future. You should be able to enter your network name, description, and setting up the member name.
If anyone needs help while you're doing this, just raise your hand, I'll come over to you.
Okay. And these steps are available in the GitHub repo, so if you're running a little bit behind, let us know.
The difference between a member and organization?
Same.
For everyone. Do you want to tell me?
Yeah, you can cover that one.
Okay. So, member and organization.
And also we'll make these slides available after the presentation, so if you wanted to go through this and also access some of the Blogger resources, you'll have access to a lot of this. All right, so all of these steps are available in the GitHub repo, so I'm gonna keep going to where we don't just get stagnant. So all of these links will be available to you after the presentation, but here's some additional blog posts on how to launch a simpler Fabric application, GitHub repos for this workshop and other resources. And on this, I'm going to hand over the mic to Jonathan to talk more about the why and our approach and more an in-depth view of AMB and KillDB.
Cool. Thanks, Lana. So I'm John, and basically I'm kind of the entertainment for the next 20 minutes while these networks are starting up. So I'll do my best to not go for too long so we can get back into the more interesting part, which is going through the demo. So let me quickly see how much time. Okay, cool. So really, and I'm happy to answer any kind of, there's a question on HIPAA and other stuff, maybe after, just come find me. I'll be milling around trying to help folks through the demo as well. But I wanted to take the next little bit of time to talk about just why we're even here. Like what did AWS launch, kind of what our thoughts were around some of the use cases that we saw and some of the services that we have. And we kind of did a little bit backwards because we kind of alluded to some of this to get you started with the demo. But we'll take a little bit of time to go through it and then go through some of the features that we've got. And then once again, happy to talk one off on if you got any more questions on how things work and certain functionality bits. So, you know, if we kind of go back about a year or so ago, you know, AWS has been doing stuff in the blockchain space for a while. We've got large exchanges like Coinbase running on us. We've got a variety of partner frameworks running. And customers would come and run this stuff on AWS and also come to us and say, hey, we really need help running this stuff. We want to run blockchain. You know, can you help us deploy this stuff in the cloud? And you know, we've read the news. We've been working with customers. We've looked into this technology before. And if you know, we kind of go back into 2018, there was a lot of more hype around these technologies. And what we really wanted to do was try and figure out, well, what were customers trying to do with this stuff? In AWS, we don't really build stuff because we think a technology is interesting or it kind of becomes popular. We really try and work backwards from what customers are trying to do and figure out what's the right approach to help them do that thing versus we have to use technology X or technology Y. And so we started asking these customers, well, what do you want to use blockchain for? What are your use cases and what are you trying to do? What we found was that there are really two buckets of use cases, and kind of you got to talk about one to really hammer out the other. And so I'll go through each and a little bit of background around kind of what we did to address each. So in some cases, we talk to customers and say, hey, we really want to run blockchain. But we go into kind of, well, what are you trying to do? And what they really wanted to do was have an immutable like transaction log of every state change that happened to their data set or every transaction that happened. But they wanted to do it with like a centralized system. Like these customers had a MySQL database with an audit table and ways to secure the audit table. And then they got audited, and it's hard to kind of painful to secure the audit table and then supply the auditors with that information. And what they really wanted was a way to say, look, I'm in a highly regulated industry, or I'm in a world where any kind of problems or tampering with the database could mean millions of dollars of auditing or other kind of deep dives that are needed. So how can I get a database technology that has this component in it? And this is that first set of customers. And so what we found was today, you know, people are using traditional database technology or trying to build a kind of a ledger functionality to say, look, I want a database with an immutable state change. Okay, so that's great. But then why are these people talking about blockchain? Well, a lot of these customers read about blockchain. They heard that there's a component within blockchain called a ledger. Now, we all know blockchain is a lot more than a ledger. It's got consensus, it's got a smart contract interface, all this stuff. These customers didn't want any of that. All they wanted was that, not even the full ledger, they wanted the journal component of the ledger, which is that kind of immutable state change transaction history. So, but there isn't really a ton of that technology out there in databases. They end up at blockchain, and they get stuck with the technology that's overkill for what they're trying to do, especially when you look at folks trying to run a blockchain network that they're the only member in to try and get that ledger out of it. You know that something is typically up with the way they're thinking about that stuff. So we, there we go. We launched a service in preview at our big developers conference last November called reInvent, a new service called Amazon Quantum Ledger Database QLDB. And the goal of that service is to do exactly that for these customers that really don't have a decentralization problem. They want to run a centralized system, but they want this immutable transaction history as a core component of their database. So this is in preview right now, QLDB. And the goal here is, it's immutable, so it has this immutable record. Cryptographically verifiable. So an important part is in this database, you need to be able to have a way of showing did anything change or not to make it independently verifiable. So QLDB has a mechanism to do that. Highly scalable in the same way that we've got other database services in AWS like DynamoDB, where it's kind of easily scalable and kind of pay for use. And easy to use. That I think one key thing with this customer segment is that, once again, they didn't want to write smart contracts. They didn't want all this additional functionality. All they wanted was a database. What do databases, what engineers typically use? SQL. And so you want a SQL-like interface to be able to easily query the database, update, and things like that to make it simple. Real quick, this is probably a huge refresher to the room, but I keep using some of these terms, so we can quickly go through. When we talk about a ledger, what do we mean? Because I think oftentimes people talk about ledgers and there's DLT and other stuff. So when we say ledger, what do we mean? Because QLDB is not a DLT. It's a highly available database, but it's not distributed. It's like a database technology, same as like if you had a distributed database like MongoDB or something like that. So DLT and some of these terms get thrown around. When we say ledger, ledger really has two components. And if you think about QLDB, it's a managed version of these two things. The first is the journal, which is that hash-chained immutable transaction log. And if you think about QLDB, it's kind of a new purpose-built database that builds the full database off of that transaction log. On top of that is obviously the thing that your application is going to interact with more, because odds are for everything that you do, you don't want to see every single thing that happened to get the state of the world to where it is today. You're going to want to know, like, what's the balance of my bank account, not everything that's happened. That's where the current history database shows up. It's indexed, so it's higher performance. You're going to be querying it to see kind of what your data is. But if you needed to go back in time to see everything that happened or you got audited, you've got full access to that journal as well. Real quick, QLDB, how it works, kind of like what I described. You add data to the database. It adds those transactions and state changes to the journal. It indexes and adds it to the current history, so you kind of see the current state of everything. And then if you want to get a cryptographic, you can get a digest out of that to show that the journal is what you think it is. And that's kind of the cryptographic variability part. Why does immutability matter? Well, kind of some of the reasons that we talked about already. First of all, for system of record applications, it's really useful because it's a way to know that no one has tampered with all the things that have happened, or just database corruption and other things like that. And so for track and trace, provenance applications, or just like you're building a control plane and want to look at state changes or things like that, all these things are helpful for like system of record things. Improving data tracking or auditability, those are kind of important too. Where an auditor comes, you can present them the journal versus having to go prove that your audit table wasn't changed. And also, using QLDB reduces the implementation effort, that there are kind of ways to kind of hack these sorts of things together, but QLDB is like a one-click solution, very scalable, and kind of all the things you'd expect out of a purpose-built database solution out of AWS. So we talked a little bit about that first bucket of customers that was, look, I don't need decentralization. I just want a centralized database that makes it easy to kind of keep everything immutable and have a immutable state change history. The second set of customers, though, had a different set of use cases, and that's why it's important we talk about both to really hammer home the differences in these use cases and the end up kind of the services that would address each. And so this set of customers is around scenarios with decentralized trust. And we went talking to customers, we kind of saw a bunch of themes around the problems that they had that really hammered this home. I won't go through every single one of these, but I'm sure that you see these themes in your business as well, and that's what's brought you maybe here to Consensus. The first is just kind of the obvious one, that there's a lot of existing business networks today where I might want to directly transact, company A transact with company B, but the way the network's set up today, there's actually a central authority that I got to transact with. That central authority is inefficient, takes a cut of the transactions, it's expensive. I still need to audit that central authority. I still need to audit whoever I was trying to transact with to make sure everything happened the way it did, and it becomes expensive and time consuming. So we saw a bunch of situations like this in financial services. We said, well, hey, there's got to be a better way to go and do this and enable more direct independently verifiable transactions. Another one that we saw come across is, a consortium of businesses could achieve a better outcome by collaborating or sharing information. But the problem there was that oftentimes no one could agree how this IT should get set up. So it might be that I want to run the database, but other people in the consortium say, well, why should you own all the data? Or in other cases, no one wants to own the data because there's a liability or cost or kind of obligation in maintaining this stuff. And so typically one of two things happen. One is nothing, right? It's just too complicated. We don't want to collaborate. That's not, we're just going to not achieve that better state. The other thing is that all those companies get together and create a joint venture. That joint venture is the thing that owns the IT, and that's also pretty clunky because you're going through all these hoops just to build kind of a system to make everything more collaborative and achieve a better outcome. And all these things kind of have that similar theme. It's groups of customers trying to either do multi-party transactions, trying to create a shared asset, trying to work with things that have heavy automation but need to be verified by multiple parties. And there's varying degrees of trust. I mean, in a lot of these cases, you know who your trading partners are, you know who's in your supply chain, you know other financial institutions in your world, but you don't fully trust it. And that kind of going from you're part of my company and I trust you to anything else, typically what we found with the customers that we're working with requires a different type of solution that involves some element of decentralization. And so that kind of takes us to kind of blockchain, or the way AWS thinks about blockchain solutions, which is it eliminates the need for a central authority in a business network, and it takes systems like you've got on the left, where you've got everybody interacting with one central piece or not being able to create a network like that at all, to on the right, obviously, where you've got point-to-point interaction and things are more efficient. And also kind of, in the room, you hear blockchain and DLTs and all these terms thrown around on how you define each thing. AWS, at least when we say blockchain, we actually think of it as a layer cake of technologies, including kind of the bottom layer, which is distributed ledger. On top of that, the consensus mechanism to describe what happens on the network, how does the network come to consensus on what's written to that ledger, and then finally, the top level is smart contracts. So it's not really, we think of a ledger database like QLDB, that is like a SQL-like interface and doesn't have really any of this stuff. The relationship is kind of QLDB is a ledger, blockchain uses a ledger as one of the many things it does, but everybody owns a copy of that, which is different than QLDB. Also, I'll pause for a minute. As your networks are coming up, if you see any failures that says create failed, raise your hand, we'll come over and help get you guys back on track. I'm trying to see how I'm in time, about 10 minutes left. Okay. So, we saw these customers having these use cases around, hey, groups of people trying to do stuff, any centralized database technology, whether it's a ledger, a NoSQL database, a MySQL database, wouldn't quite achieve it. But what we found was that these customers had a lot of difficulties getting started. That setting up this stuff is hard. Setting up this stuff for actual production use cases is even harder. I mean, take Fabric. You need an HSM, right? You don't have an HSM, you shouldn't even get started in a production standpoint. You don't have your root CA secured. How do you run these things in a highly available formation? How do you make sure your storage is scalable, metrics, monitoring? And then if you're running a permissioned framework, how do you get other people even in the network? You've got to deal with networking and all sorts of stuff to do it. It can get very expensive because oftentimes what you would do is you might need a consulting arm to come in, or you pay for proprietary technology, or all this kind of expense and time just in order to get a POC started up, or the fear that, all right, I got a POC set up, but is it really going to be cost effective for me to get this thing into production? And so based on some of that feedback and these use cases that we saw that kind of are uniquely addressed by decentralized technologies, we launched another service at reInvent last year called Amazon Managed Blockchain. And actually that service went into GA 2 weeks ago, so not in preview anymore. It's available in the console to use, as you guys are using it right now. The goal of the service is to make it really easy to create and manage these scalable networks using popular open source technologies. And the two technologies we offer now are Fabric and Ethereum, which is coming soon. Soon, unfortunately, equals soon. But we are actively working on it. It'll be available in a bit. Fabric is available GA today. But the goal of these things, both of these projects are really great, have a ton of great development going on, and we're excited to start partaking in some of that as well. Also, if you think about it, just these networks are going to be expansive, right? They're already, obviously, Ethereum is a large public network. These fabric networks are going to be expanding beyond clouds. And having an open protocol is super important in the proliferation of this technology, making it easy to use, making it transparent, and having kind of many different entities join together in creating these networks, or joining a public one, obviously, would need a public protocol there. A couple high-level features, and you'll kind of go through some of this in the workshop, so I won't spend too much time here, but obviously fully managed, couple clicks, you can get a lot of this stuff up. 2 open source frameworks. The service is built in kind of an interesting way, and I want to highlight that for a second, in kind of the way that these networks come together. So if you take a typical AWS cloud resource like an S3 bucket, I can invite you all to use my S3 bucket, allow you to upload things or download things, but it's still my bucket. I could shut off your access, I could delete the bucket, I could delete my account, and a lot of customers are coming to this technology because they don't want to kind of hand over the reins of the success of something to somebody else. The whole goal is to have an equal seat at the table. And so we actually built this a little bit differently than most cloud resources, where I can create a network, I can invite all of you, and I can leave, and it's not like it's my resource. That network will be totally fine and running. And better yet, there are tools we built in where the network, all of its participants, can vote on the state of certain things in the network. Like if we want to add an account, 100% of everybody or 80% of everybody needs to agree to add that account before an invite's sent. Same for removing. If somebody's doing fraudulent activity, we want to kick them off the network can vote on removing people as well. So the idea is, if you're building a technology that truly enables people to come together and have equal footing, it wouldn't make sense to have any one person own that network. Now, over time, we will build ways where there's, in some cases, some things that are useful to have an ownership. Like if you're running a supply chain, you might not want that network to be alive outside of your supply chain. If you're using blockchain more as like easy data integration, having one pane of glass view over stuff. So there are caveats to that. But for the case of like a lot of the financial institutions we're dealing with, they wouldn't really want to have that any other way. AMB is reliable and scalable. We actually, for Fabric, utilize the same journal technology that underlies QLDB instead of Kafka, which is an open source project that is typical in Fabric deployments. We believe it's better because of some of the things the order needs to do don't line up great with Kafka. Kafka is great. We have a managed Kafka service in AWS as well, but there's some tweaks. I can get into that offline on more details. Low cost, you pay for what you use. All of our pricing is on a website. You can see exactly what the dimensions are. And if you have a larger, obviously, peer node, you'll pay more. Smaller peer nodes, you pay less, and everything is pay per second. Yeah.
What features are that you like? So for instance, can I store something on the network using the console?
Consoles right now more for like network creation, peer creation, that sort of stuff. We expose a bunch of endpoints like the Fabric peer endpoint. And so if you wanted to say submit a transaction and invoke chain code, et cetera, you would do that through the Hyperledger Fabric CLI that you download on EC2. So you can't do that through the console yet. And finally, it's integrated. And some of these features are coming soon as QLDB becomes generally available. You'll be able to push blockchain events into off-chain storage in QLDB, and over time we'll add more AWS integrations as well. So I've got only a couple minutes left. Let me see kind of this slide. Somebody asked earlier what the difference between a starter edition and a standard edition network are. And so both are production grade. It's really just the kind of scalability of one versus the other. So the starter edition, membership is less per hour. I think it's 35 cents an hour, I think, or 30 cents an hour. It's you have kind of less peers, less members, smaller nodes, but still everything's running in highly available. It could be a production grade system. For standard edition, it's kind of you get an ability to have more networks, larger peers, and kind of more availability for some of the Fabric stuff. And so either one of these things is a production grade system. It's just how much do you want to scale and how much throughput do you want to run through the order. So and this is specific to Fabric. I guess we can go through the transaction. How many people here are pretty familiar with how Fabric works, the transaction flow for Fabric? Okay, so show of hands, most people are not. So I'll quickly go through this, and then that will kind of talk a little bit about in the demo, kind of what you guys are building. So the way this kind of maps to that drawing that Lana showed earlier, which had that kind of VPC with a bunch of different members, and remember all those members are in different AWS accounts. So the way that you're building this, it's not like I've got 3 members in one AWS account. You can do that if you wanted to say simulate what a 3-member network would look like, but when you're inviting different entities, these are actually separate AWS accounts, which makes sense. Your businesses are probably going to have different accounts. So the way this maps up to that first thing, first you can kind of see this is kind of a transaction flow of what happens when you want to submit a transaction. So when we start at the client, that client maps to an EC2 instance that has the Hyperledger Fabric CLI or SDK running on it in your VPC. And what that VPC is connecting through is when you create a VPC endpoint for your network, that exposes your Hyperledger Fabric ordering service, their Hyperledger Fabric peers, your Hyperledger Fabric certificate authority, all through that VPC endpoint. So that node on EC2 that you own has a client. It'll submit a transaction to the peer. Now, one interesting thing here is that in Fabric, depending on the endorsement policy of the network, which is how many different members need to basically say, yeah, this looks good, the client is actually communicating directly with those peers. And so if you think about it from a networking perspective, that client doesn't just communicate with your peers, it actually communicates with everybody's peers. And the VPC endpoint enables that networking in a secure way. And so your Fabric client is communicating with all the peers in the network to say, hey, I've got a transaction, validate it. And that's the second thing right there is all the peers in the network, not just yours, receive the transaction, start simulating it, and if it looks good based on all the rules, it'll endorse it and then send that transaction back to the client. So the client's collecting these endorsements, and depending on the endorsement policy of the network, like 3 out of X members or whatever, it'll keep collecting stuff until it reaches that threshold. So basically, it's sending stuff into the managed blockchain service, blockchain nodes, across all organizations, sending it back. I'm using organization and member kind of interchangeably, by the way. Client gets it back, it's the EC2 machine. Then it submits that kind of endorsed transaction back to the ordering service, which is also exposed via the VPC endpoint. And even though it's one endpoint, we're running multiple orderer nodes and a high availability configuration in the background. The orderer gets it, verifies the endorsement policy, and then batches all those transactions in order into blocks, and then send those blocks back out to each peer that's running in the managed blockchain service. And then each peer that's not on here does one final validation check before committing that transaction as a valid transaction to the ledger. So that's kind of a quick view of the overlay of this kind of logical transaction flow over the Fabric services that are provisioned up. So I've been talking for about 20 minutes. I want to check in. How many people have their member created or that's creating? And how many people are still creating? So more created, some are still creating. I guess for those who are created, I think the next step is creating a peer, and then in that GitHub repository, those are the next steps on basically creating your client machine on EC2, which is that client machine that's kind of logically there, and then enrolling, getting your network kind of set up. And so for those of you who have your network in created state, proceed through the instructions, and then if you run into any issues or think anything's up, raise your hand. I mean, we thought about kind of doing it through here, but what we found is that people go at different paces, and then kind of we leave you behind. So I'd say go at your own pace, but make sure to raise your hand if you think you have an issue, and we've got a bunch of people around the room who can help out. For those of you who are still in the creating state, I'll go through a couple more things, and in 5 minutes we'll check in, and if it's still not ready, we should come over and see what's going on.
Yeah, okay, sounds good.
Okay.
So the next one will be adding here. So this is going to
So this is kind of relevant as well. So Hyperledger Fabric, we've made a couple kind of changes in the way that we're deploying it. A couple ones that I wanted to call out is one is the ordering service. I kind of talked about this a little bit. We use the same underlying journal technology in QLDB. If you think about what the orderer does, that's like your single source of truth, right? Like when a new organization comes up, it syncs a bunch of information from the orderer for that organization. So that thing needs to be available and durably store data. Kafka is great, but you don't really think of Kafka as like a durable data store that scales out forever. If you think about also the ordering service, it needs to store the ledger, and so it's going to need kind of elastic storage as well. So we built all that stuff into our ordering service with the idea that we need a bulletproof, resilient, high-performant ordering service that's going to kind of hold on to that information forever. Second thing is with the certificate authority, we do use AWS KMS technology under the hood. And so you do have HSM grade tech guarding your root CA. If you're running it yourself in open source, you would need to go provision some sort of HSM to be able to hold on to that root certificate. And I think I'll maybe end on these couple of slides. I'm talking a little bit about some of the, because this question comes up a lot of, well, how do I do access control with Hyperledger Fabric? It seems like most people are not quite as familiar with some of the details. So Fabric offers a couple features that we find are super useful for, Fabric only does permissioned blockchains. And so one question is, well, how do I do access control, right? Like I might not want every single person seeing every bit of information. So Fabric has two controls for this. One is kind of more of a brute force thing called channels, where if I have, say, 10 organizations or members in a network, I might want 3 on one channel, 3 on another channel. And a channel is basically like a subledger. So if you're on that channel, you can see transactions. I mean, you have read-write permissions, so maybe you can only read or write or do both. But if you're not on that channel, you can't do anything with it. So you can be in a network, but not actually have access to a channel. And so channels are one way to start like compartmentalizing who can do what on a network, who can see what or write in what. But a second feature is kind of a sub-channel feature, which is called private data. What that allows you to do is have two actors on the same channel do a transaction, but have everybody else in the channel not really know kind of what happened. And so, yes?
Is that channel permanent? Like the business relationship is fluent. Like you have ABC is in one channel, and then 1 to 3 in another channel, but then half a month later, and then 1 and BC would do business together. So is that channel permanent?
You can add and remove members from a channel. It's kind of like, if you think about a channel, it's like a sub-ledger. It's like its own ledger, you can even think of it as. So you can add and remove people in the same way of like kind of any ledger that you're on based on what it is. But it's not like if you had 3 people on a channel and one person leaves, it's not like all the transactions they were a part of would also get ripped out of the ledger. Like that's kind of by design. Everything that happens up to a point is immutable, but people can be removed from that channel depending on if business arrangements change. Does that make sense?
So the people can be removed by the administrator.
Yeah, I think it's, I'm trying to jog my memory on exactly the rules. I mean, you could, using the actual Amazon managed blockchain voting APIs, you can rip somebody out of the whole network. But let's say a situation where you don't want somebody to leave the network. You just want them to be off of channel A, but you want them to stay on channel B or some like channel related thing. I'm trying to think, I don't remember if you can vote somebody off or whoever has admin rights can kick you off, but there are mechanisms where you can get people to be removed from the channel. We can take that offline though.
So what if that node wants to, they have the business relationship between the channels, like they participate in the channel group 1 and also they participate in the channel group 2. What do you do with that node?
I think that's more about the application. I don't think this is much about the node.
Yeah, let's dive in and take this offline, because I want to
Yeah.
make sure that I'm answering the question directly. So I'll come and find you after I'm done chatting here. We can get into more of channel operations and things like that. But real quick, out of private data, so this enables kind of sub-channel permissioning. And so that's important because you might have 30 people on a channel, but you want certain transactions to be private. And the way that's done is those members have side databases that store information. So I'll have my side database. I know those private transactions, and whoever I've transacted with has the corresponding information in their side database. But then what gets committed to the channel that everyone sees is some sort of hash that doesn't make sense to anybody who wasn't part of that transaction. So people see evidence that something has happened, and that's useful because it's almost like checkpointing against a shared ledger that other people have, so kind of more of a immutability aspect that's maintained across the whole community, but no one really knows what happened, who it happened with, and it's an ability to kind of do that. I guess kind of the final note before I'll sign off and hopefully everyone has their networks created is just the idea of endorsement policies. And this is, again, configurable, I think, at the chain code level. But when I do a transaction, how many different organizations need to endorse it? Once again, another feature to kind of drive consensus through the network, and it's also configurable. So I think I'm going to stop there. Happy to chat on kind of the slides that were coming on different use cases. Obviously, we've got a lot of different customers from financial services, supply chain, Fortune 500 to startups using this. We've got some information on our websites and press releases on what people are doing, but happy to chat more about what we're seeing. My email is johnfritz, JONFRITZ @Amazon. So if you've got any interesting use cases or questions, feel free to drop me a note, or Lana or Mert or Carl as well. But anyway, hope you enjoy the rest of the demo. And once again, raise your hand if you think you're getting stuck. We want to help make sure that you get through this quickly. So we'll pause for now. We might have some closing remarks, but let's, I guess, now focus on the GitHub.
Yeah, so we'll be walking around and I'll probably bring up the GitHub repo here, and then if you have any questions, I will either show it on the screen or we'll stop by and talk to you in person. Also, we're hiring, so.
Yeah, if you're interested in Fabric, Cloud, Ethereum, et cetera, come drop us a note. We're looking for developers of all levels, solutions architects of all levels, and anybody who's interested in getting involved. Thanks a lot.